Power frequency control method of electrical equipment and the Internet of Things technology. The power frequency of electrical equipment is related to safety of the equipment, but the traditional control method is difficult to guarantee the safety of the electrical equipment because of the small difference between the active characteristics of the power information extracted by the traditional control method. Therefore, this study proposed a power frequency control method of electrical equipment based on Internet of Things technology. Firstly, power supply information of electrical equipment is collected based on the Internet of Things technology, and then the collaborative model is established to extract the frequency of fluctuation characteristics of a power supply. Based on this frequency inflection range is located. The node information is comprised singing on the basis of two feature date processing, and then Shortcut algorithm is used to control the frequency fluctuation trajectories of the power supply. Four groups of the variables were set to test the safety performance guaranteeing effect of the control method. Compared with the traditional control method, the safety factor of the electronic equipment is 7.96%, higher than that of the traditional control method. It can be seen that the method in this paper can effectively improve the use safety of electrical equipment. With the rise of network science and technology, foreign countries first began to study signal transmission control theory through mathematical abstract hypotheses in 1766. After that, for nearly two countries, people have been combining mathematically abstract hypotheses to control the synchronous transmission of signal. The domestic research on this work started late, but with the continuous depending and innovation of various science and technology, various synchronous control strategy of method has different research programs. Among them, in reference 1, a 5 high-frequency ice melting excitement power supply designed to achieve large capital output of the system through parallel inverter models, and then the drive signal of the inverter switch is generated by carry base shift technology to reduce the work frequency of the switch, so as to improve the control effect of the output frequency of the power supply. In reference to, on the basis of determining the power frequency control range of the power electric interface and the equivalent integral and the different adjustment coefficient of the power system are calculated, and then the frequency control of the power system is realized through the frequency support between multi-synchronous networks. On the basis of the above research, this paper advanced the existing frequency control technology of different objectives to carry out optimization research on the power frequency control of electrical equipment. The main work of this paper as follows: collect power supply information of the electronic equipment based on Internet of Things technology and establish a collaboration model so as to extract frequency fluctuation characteristics of the power supply. By potentiating a frequency fluctuations range and on the basis of two characteristic data processing comprised things node information is used, and then Chow's algorithm is used to control the power frequency fluctuation trajectories so as to realize the effective control of power frequency. The method design: collect electrical equipment power environment information based on the Internet of Things technology. The Internet of Things technology includes information collector technology, wireless network communication technology, wireless potentiating technology, and smart technology. The Internet of Things technology is used to monitor the power supply of electrical equipment, establish a collaborative model to extract the characteristics of power frequency fluctuations on the premise of the integration of the digital control platform and the Internet of Things technology according to collaborative mechanism of the Internet of Things and electrical equipment. A collaborative model is established to extract the characteristics of power frequency fluctuations, assuming at the options risk of the control platform is neutral, and the various data in the platform can be regarded as a single mechanism of approximate project-directed changes. A two-state model of nominal distribution conforming to a signal period is created. In the based management model of electric equipment, considering the flexible control performance program, it is assumed that the designed maker adjusted the original options applying according to the actual operating conditions of the electrical equipment within a certain period of time. So the experimental study, in order to further verify the control effect of the research method, the control method is applied to a stimulation test environment, and a group of traditional control methods are used as control group to compare the control differences between different methods. The experiments selected a certain electrical equipment in the power plant as a test object, uses simulation software to build a testing environment, and sets the simulation experiment parameters shows in Table 1. According to the simulation parameters shown in Table 1, the test environment was established to test the control performance of the two methods. Figure 1 shows the changes in the electronic circuit, electronic power, rotor angular speed, and control signal of the generator's electronic circuit. Electronically power, rotor angular velocity, and control signal after controlling the power frequency of the electronic equipment under the application of the two methods. From the observation of the curve of the above 4 groups of test results, it can be seen that on the basis of controlling the power supply frequency, the method in this paper accurately allocated data to the control center, so that the electronic circuit equipped electronic power, rotor angular velocity, and control signal of the generation of the entire electrical equipment are constrained within the limited value. However, the traditional method doesn't restrict the 4 parameters, which leads to the data overrun and bring great security risks for the use of electrical equipment.